All right. In today's video, we're going to be going over question 3 on the homework to get mastery points for 5A. So the question starts with consider this system of differential equations. Ax plus 3y is equal to x prime, and y prime is equal to negative 2x minus 3y. So the first thing we have to do is formulate the system as a vector of differential equations, and then find the eigenvalues for the corresponding matrix. So here's the way to start this. We're going to start with understanding mainly that that x with a line underneath it is going to be equal to x over y, is going to be equal to the vector is equal to the vector xy, and then x with the line underneath it of x prime is the derivatives. So we can set the derivatives equal to a matrix multiplied by this xy. So if we were to do the matrix multiplication of a x like that, this x factor will go to the top here. So like here we have a 4 times the x, that's going to show up right here, and here we have a plus 3y that shows up here, and so on. So the negative 2 and negative 3 show up right there, which happens as a product of the matrix multiplication. And then our next step is using a little trick of lambda 1 plus lambda 2 is equal to the sum of the diagonals of A, and lambda 1 times lambda 2 is equal to the determinant of A. We can set up this system of equations, and solving them gets lambda 1 is equal to 3 and lambda 2 is equal to negative 2. From there, we now did part A. We can now do part B, which is compute the general solution by plugging in lambda 1 and lambda 2 for an equation of what eigenvectors or eigenvalues actually represent, which is eigenvalues are the solution to the equation A eigenvalue is equal to a vector times an eigenvalue. So solving for this equation and simplifying it, we get A minus the eigenvalue times the identity matrix times V is equal to 0, and you can solve to get V is equal to negative 3, 1, and similarly we can use the other eigenvalue to find the other eigenvector, which is 1, negative 2. From here, we can set up our general solution with C1 e to the 3t, so C1 e to the eigenvalue times t times V1 plus C2 e to the negative 2t times V2. And now we did part B. Part C is suppose that these values represent populations or species of a population. Suppose they represent populations. If both the populations start at 1 at time equals 0, what happens as t grows? And we can see here that that solving for these equations with the initial parameters, as shown before, get us these two equations, which, if it's not obvious just by looking at them, we've also graphed them to show that as the red line represents x, as t grows or t increases, x increases, and the blue line represents y, so as t grows, y decreases. And that's how we get to our conclusion, which is answering part C. Thank you.